Hi students, once again I welcome you all to my channel, Abrar Sir classes. Today we'll be seeing some important problems on the topic application of dimension, which comes in the chapter units and dimensions. This is part 1 of the video. This is the first problem. The equation p plus a by b square into b minus b is equal to constant. The units of a are. See here, p and a by b square are together. Therefore, the units of p should be equal to what? The units of a by b square. That is, p is equal to a by b square. You are supposed to find the units of a. Therefore, a is equal to p into v square. I can write. What is P? P is nothing but pressure. Pressure is equal to what? Pressure is equal to force by area. Force by area. Right? That is force by area into what is V? V is volume. The whole square. What is the unit of force? They are given in series system. Okay, that is time. Okay, I'll write dy and whatever they are given. Okay, time divided by what is the unit of area in a series system? That is, you have centimeter. Okay, centimeter square into what is the unit of volume? Unit of volume is centimeter cube raised to the power 2. Now here what happens? Time by centimeter square into centimeter to the power of 3 to 6. Here I can just write down this one, time into power, okay, centimeter to the power of 6 minus of 2, right? Okay, 6 minus of 2. That is equal to how much? 9 into centimeter to the power of 4. It is the answer, 9 into centimeter to the power of 4. This is the, hope you understood. Only one thing, okay, p is equal to a by v square. If you equate, the units of p is same as what? The units of a by v square. Simplify for a, p into v square. You know what is pressure, force by area. You know how to write area, centimeter square, and you know how to write volume, okay, centimeter cube. And area is what? This is area. Area is centimeter square, okay. This whole thing is area, centimeter square we are writing here. Hope you understood. After simplification, you will get 9 into centimeter to the power of 4 is the right answer. Next problem. Take up this problem. X is equal to what is given? 3yz square. Find dimension of y in MKSA. That is meter, kilogram, second and ampere system. If x and z are the dimension of capacity, okay, x is what? Dimension of capacity. That is capacitance, okay, capacitance. And capacity is for, here they have given, this is capacity, okay. Now what is z? Z is what? Dimension of magnetic field. Magnetic field. It is denoted by P. Capacitance is denoted by C. Okay. Now you are supposed to calculate the dimension of y. X is equal to what? 3y z square is given. Therefore, I can simplify for y. Y is equal to what? X by 3 z square. Now, if I write in dimension, 3 will not be there because 3 is a constant. Therefore, dimension of y is equal to what? Dimension of x divided by dimension of z square. Okay, dimension of z square. You can write. Okay. Now, what is X? Dimension of capacitance. Okay, what is capacitance? How to calculate C? What is capacitance? C is equal to Q by V. C is equal to what? Q by V. Where Q is what? Q is nothing but what? Charge. And what is V is nothing but potential difference or voltage. Okay, potential difference. We simply call that as what? Voltage. What is charge? Charge is equal to what? Current into time. That is current into time. Okay, so what are the dimensions of Q? Current, we should take current as what they have given. Okay, ampere. Okay, A into T, that is AT I can write. Okay, what is dimension of potential difference? What is potential difference? Potential difference, V is equal to work done by charge. Work done by charge. What is work done? Work done is equal to force into displacement, right? Force into displacement. Force into displacement. Okay. Force. Okay. What is meant by force? That is mass into acceleration. I can write m, right? Mass into acceleration. What is acceleration? Rate of change of velocity is called acceleration. What are the dimensions of? Because we know what is F. F is equal to ma. Correct? No. What are the dimensions of force? Mass into acceleration. What is acceleration? Acceleration is again given by what? Speed by time divided by time. That is velocity by time. What are the dimensions of velocity? L t to the power of minus 1. What is velocity? Distance by time. By time, this is acceleration is rate of change of velocity. So I can write L t to the power of minus 2. Okay, what are the dimensions of force? ml t to the power of force, ml t to the power of minus 2. Okay, ml t to the power of minus 2 into what are the dimensions of displacement into L. So I can write down this one as work done is equal to how much? M L square L into L square t to the power of minus 2. Okay, work done. Dimensions of work done. Okay, that is W. Okay, W I can write what? M L square t to the power of minus 2. Now, okay, that is work done. Work done is how much? M L square t to the power of minus 2 divided by charge is what? AT. Charge is AT. So what are the dimensions of V? We got the dimensions of V as what? Dimensions of V is equal to how much? M will be as it is, M L square, okay, t to the power of minus 2 minus 1, minus 3, okay, e to the power of minus 1. Write down this in that order, okay, MLS, see, M, L, T and A we are writing. We are writing in this order, okay. First is mass, kilogram, second and ampere, that is current, okay, MLT, I, like that. Now what is C? C is nothing but dimensions of C is equal to dimensions of charge is how much? AT divided by how much is V? Just now we got, that is M L square t to the power of minus 3 a to the power of minus 1. Now you simplify, okay. simplify and better you remember the dimension of capacitance. That is equal to m to the power of minus 1, okay, L to the power of minus 2, because these two come in the numerator, and t to the power of 1 plus is to the power of 4, and a to the power of 1 plus 1 is a square. Okay, m to the power of minus 1, L to the power of minus 2, t to the power of 4, and a square are the dimensions of capacitance. Now, okay, we calculated the x. What is z dimension of magnetic field? Z is equal to dimension of magnetic field. How to calculate the dimension of magnetic field? Let us say we have an equation. The force F on a charge Q moving with velocity v in a magnetic field B. In a magnetic field B is given by F is equal to Q into V into P. From here we can calculate P. P is equal to what? F divided by Q into V. Okay. What are the dimensions? B, what we got? B is equal to, what are the dimensions of force? Just now we calculated. How much is force? Force is nothing but M L T to the power of minus 2, because mass into acceleration, divided by charge is how much? Current into time. A into T. How? Dimensions of V just now we calculated. Correct? No? That is, this is not V. Okay, V is what here? Velocity. Okay, dimension of velocity. What is velocity? Velocity is equal to distance by, do not substitute this V here. Okay, this is what? V is velocity. What is velocity? Velocity is equal to V is equal to, dimensions of V is equal to L, distance, that is speed by time, of minus 1. Right. Okay, this is velocity here. Okay, this is velocity, not the potential difference of voltage. L T to the power of. Now from here we can calculate the dimensions of B. The dimensions of B will be how much? I write here, dimensions of B is equal to, you will get M, okay, M, first not write M, and then is any L is there? No, L and L gets cancelled here, okay. T is there? Yes, T is there. T to the power of minus 2 plus 1 is T to the power of minus of C. This T and this T inverse gets cancelled, okay, therefore T to the power of minus 2. Alright, and A will come in the numerator. Now we got the dimensions of capacitance and magnetic field. Now we have to simplify for this equation. Y is equal to X, I will write it here, Y is equal to, dimensions of Y is equal to dimensions divided by Z the whole square. Okay, hope you understood. Okay, I have written the equation here, X by Z. How much is X? X is nothing but capacitance. X is nothing but what? Dimensions of capacitance. Y is nothing but what? Y is nothing but B. Y is nothing but what? B. How much is X? M to the power of minus 1. I will write it here. Dimensions of capacitance. M to the power of minus 1. L to the power of minus 2. We got T to the power of 4 and a square divided by what are dimensions of z? We got m t to the power of minus 2 a to the power of minus 1 the whole square. Just check it out once again. X we got m to the power of minus 1 a to the power of minus 2 t to the power of 4 a square, right? Z is how much? M t to the power of minus 2 a to the power of minus 1. Now you simplify for y. That is equal to m minus 1 m to the power of m square will be there here. Okay, better you write down like this, otherwise it leads to confusion. M to the power of minus 1 a to the power of minus 2 t to the power of 4 a square divided by square it m square to the power of minus 4 a to the power of minus 2. Okay, that is equal to m to the power of minus 1 plus 2. Here plus 2 will come to numerator, that is m to the power of minus 3 l to the power of minus 2 will be as it is, t to the power of 4 plus 4 will be 8 l to the power of 2 plus 2 will be 4. Okay, this is the dimension of m to the power of minus 3 l to the power of minus 2. We will see the answer, m to the power of minus 3 l to the power of minus 2, right? T to the power of 8 and a to the power of 4. Okay, last option is the correct option. Hope you have understood. Now we'll see the next problem. If L, C and R denote the inductance, capacitance and resistance activity, the dimensional formula for C square L R. Okay, what are the dimensions of, what is meant by inductance? L is what? Inductance here. What is the energy stored in an inductor? Energy stored is equal to half L I square. Okay, from here you can calculate what? L. Understood? L is equal to, that is 2 into E by I square. So here dimensions of L will be equal to what? Dimensions of, that is what is energy. Energy is the capacity to do work. Okay, that is work done. Okay, dimensions of what? E divided by I the whole square. E is equal to half L I square. L will be equal to 2E by I square. Okay, that is, just now we calculated what is the dimension of work done. Work done is m L square t minus 2. T minus 2. T to the power of minus 2. Okay, work done. Always remember the dimensions of, okay, energy, that is work done. Okay, energy or work done, and this is capacity to work done, and the dimension of force. Okay, you have to remember, and dimensions of capacitance to remember. Okay, to remember. Always remember the dimensions of energy or work done, and then force, and then what? Capacitance. This will help you out. Capacitance. Okay, to remember dimension of what? Work done or energy, force and capacitance. Okay, that is m L square divided by I is what? I is nothing but a square. A equals. Now I can write the dimensions of L as what? I can write the dimensions of L as then L is equal to m L square t to the power minus 2 and a to the power of minus 2 I can write. Okay, dimensions of C, just now we calculated. Okay, C, I told you to remember. Okay, C is equal to how much? M to the power of minus 1, L to the power of minus 2, T to the power of 4 and A. What are the dimensions of R? What is R? Is nothing but R is equal to V by I. V by I. Now dimensions of R is equal to what is V? V is nothing but the potential difference. In the previous problem we calculated how much is potential difference, m L square t to the power of minus 3 a to the power of minus 1. Okay, because what is V? Work done by charge. You know the dimensions of energy. Okay, charge is I to t. Once if you remember this one, okay, you can derive any dimension, provided you should know the dimension of energy, that is R work done, force and capacitance, divided by A. That will give m L square t to the power of minus 3 a to the power of 1 is there here, 1 equal minus 1 equal minus 2. Now we got the dimensions of what? L, C and R. What they are asking? C square into LR. Okay, you have to find the dimensions of what? C square into L into R. That is nothing but what? C square means C square L into R. That is equal to C is how much? Here, if I square this one, it will be what? M to the power of minus 2, n to the power of minus 4, t to the power of 8 and a to the power of 4 into what are the dimensions of L as it is write down, m L square t to the power of minus 2 a to the power of minus 2 into what are the dimensions of R. R is here, m L square t to the power of minus 3 a to the power of minus 2. You just simplify this one and you get the answer. That is equal to here, see, m gets cancelled, m and m square, this will not be there. Okay, now that is m to the power of 0 I can write here. Right, now come to L. L is how much? L square, see, L also gets cancelled. Okay, L square and L square is L to the power of 4. Okay, L to the power of 0. Okay, what about T? T to the power of 8 minus 2, minus 3 minus 2 is minus 5, minus 5 plus 8 is plus 3. T to the power of plus 3. What is A? Or A or I, one and the same. See, dimensions of A is same as dimension of I. Do not get confused. Okay, 9. Here, A to the power of minus 2, A to the power of 4. Again, it gets cancelled. Again, it gets cancelled here. I to the power of 0. I to the power of 0. Now let us see where is the answer. M to the power of 0, L to the power of 0, T cube I. T cube. If you go to the higher classes, you will understand this. You can do this by only one step. This you can do only by one step. Okay, once if you go to class 12, there you will be learning what? A resonant frequency. Okay, C square into L into R is nothing but what? I can write this as what? C into L. Again, C into R. C into R. Okay, what is resonant frequency? We know F naught is equal to 1 by 2 pi root of LC. Anyhow, okay, you don't know this one. This is called the time constant. This is called the time constant in case of LC circuit, and this is called the time constant in CR circuit. Okay, time constant in CR circuit. Now, what is the what are the dimensions of what are dimensions of CR? CR is what? That is second in time only. Okay, T. Okay, now what are the dimensions of CL? Okay, now here F naught is equal to 1 by 2 power root of LC, or LC I can write this as what? LC is equal to 1 by 4 pi F square. Okay, Now what is frequency? 1 by time. Okay, that is nothing but what? Again, time square you will get. Correct, no? Time square you will get. This is nothing but what? Time square. Understood? So T into T square is how much? T cube. Hope you understood this in just one. This is called what? Time constant. Time constant in CR circuit. Time constant. And this is called root of LC is nothing but that is LC. If you square this one, this is also time constant. Okay, you can write as T the whole square. That is. Hope you understood this one. If you like this video, kindly share with your friends. Ask doubts in the comment box. Do not forget to subscribe for my channel. Like the video. Thanks for watching this video.